Hello everyone, I am Mrs. K. Vanitha, Assistant Professor working in the Department of ECE at K.S. Rangasamy College of Technology. Today we are going to see the lecture on TCP IP model in the course Computer Networks under the module Data Communications and Networking. So first of all, TCP IP protocol suite is nothing but a network model and used in the internet. It is a hierarchy protocol. Hierarchical means that each upper level protocol is supported by the services provided by one or more lower level model. It's a layered architecture. Here we assume that we want to use this TCP IP protocol suite in a small internet made up of 3 LANs. That is, the LANs nothing but links between the source host and the switch, and switch and the router and the switch, between switch and the destination host. So there is a link between the source host and the router and also the destination. With the help of this links is nothing but a LAN where we have switch. Layered in the TCP IP protocol suite. Layers. Here it provides a logical connections between each layers of source host as well as the destination host. There is a logical layer connection between application layers of source and destination host. Similarly for the transport layer and as well as the network, data link and physical layer. There will be a transmission medium, physical transmission medium through which the data will be communicated. So before till that there will be a logical connection at each layers. So logical connection makes it easier for us to think about duty of each layer. The duty of the upper layer, that is application transport network layers is end to end. Duty of the data link and physical layers is hop to hop. There will be an identical objects at each layers. Identical objects of the application layer is messages. Identical objects of the transport layer is segment or user datagram. Network layer is a datagram. Data link layer is frame, and physical layer it is bits. Description of each layer. Physical layer. So physical layer is responsible for transmitting bits of information. And also there will be a logical connection still between the physical layers of source and destination host, because there is another hidden layer otherwise called as transmission medium, where cable or air it carries electrical or optical signals. Data link layer takes a datagram and encapsulates it in a frame. Network layer, it is responsible for creating connection between source and destination computer. So network layer, where we use a main protocol called as IP, which defines the format of a packet called as datagram. So at the identical object at the network layer is datagram. So IP is nothing but a connectionless protocol that provides no error or flow control or congestion control, but it provides unicast and multicast routing protocols and also some auxiliary protocols. In the network layer, we also have ICMP, which helps IP to report some problems when routing a packet. IGMP, that helps IP in multitasking. DHCP, which helps IP to get network layer address of a host. Address resolution protocol is a protocol that helps IP to find out link layer address of a host. So for the network layer, we use for finding network layer address, we use DHCP. For finding link layer address, we use ARP. Transport layer, here also the transport layer gets a message from the application layer and it translates it into a mainly segments as well as user datagrams. The transport layer, we have some more protocols called as a TCP and UDP. TCP is a connection oriented protocol. It provides flow control, error control and congestion control. UDP is a connectionless protocol and also it is an unreliable protocol. It does not provide any flow control, error control or congestion control. We have new protocol called as SCTP, that is Stream Control Transmission Protocol, is designed to respond new applications that are emerging in multimedia. Application layer. Here the application layer identical object is message, and it provides a main duty of the application layer is to provide process to process communication. Some of the protocols used in the application layers are HTTP, SMTP, FTP, Telnet, Secure Shell, SNMP, and Domain Name Service, finally IGMP. This HTTP is used for accessing World Wide Web. SMTP is mainly used for electronic mail services. FTP, File Transfer Protocol, is used for transferring files. In order to access site remotely, we use Telnet as well as Secure Shell. SNMP is used by the administrator to manage the internet at local as well as global levels. DNS was used to find network layers address of a computer. IGMP used for collecting membership in a group. So it is a internet group management protocol, so that used to collect membership in a group. The next, so far we have seen TCP IP protocols used, where we have 5 layers: application, transport, network, data link and physical layer. So at each layer there will be an operation called as encapsulation and decapsulation. So we are adding extra information with the message which is transmitted from the source host through the application layer. So the method of adding extra information, nothing but headers and trailers, or otherwise called as encapsulation. So encapsulation will be done at source host. Encapsulation, arrow mark tells the encapsulation, and decapsulation will be done at the destination host. Both the encapsulation, decapsulation will be done at the router. So we are sending the message through the application layer. Identical object is in the application layer is message. With this, there will be an encapsulation of the header. Header will have some more information about the source and destination host, that is the source and destination application as well as the error control, flow control and congestion control information. Similarly, at the network layer, some more information will be added which is used to define the network layer addresses, and data link layer, which some more information will be added, nothing but headers and trailers at the data link layer, which is used to define the physical address, and finally it will be transmitted to the physical layer. And at the router, so that the encapsulation will be done at the source host, adding extra, that is header with the message, otherwise called as payload. So and at the in the application layer it is called as message. In the transport layer it is otherwise called as user datagram as well as segments, and at the network layer it is otherwise called as packet or a datagram. Data link layer it is otherwise called as frame. In the physical layer it is otherwise called as bits. And at the encapsulated information will be decapsulated at the router. So each information will be, that is added, encapsulated information will be decapsulated, so that the message will be transmitted from the router in the network layer. So encapsulation will be done, and at the destination host, decapsulation will be done. Finally, the message only will be transmitted to the user at the destination host, which is explained in detail in the slide. So at the source host, from the application layer we used the message. It does not contain any header or a trailer. Transport layer will take this message as a payload, adds its header which defines the source and destination application programs, and also some more information about flow control, error control, congestion control, where we call this encapsulated message otherwise called a segment or a user datagram. Network layer will define the source and destination host addresses with error, some error checking information at the header. Result is the datagram. This datagram will be moved to the data link layer where it adds its own header, will provide the link layer addresses. The result will be the frame. Finally, it is passed through the physical layer for transmission. Decapsulation and encapsulation will be done at the router in order to define which will be the next hop to find the shortest route to deliver the packet to the destination. Decapsulation will be done at the destination host. Each layer only decapsulates a packet received and delivers a payload to the next higher layer protocol until the message will be received at the application layer, which in turn to the user. Addressing. So we know the identical objects at each layer will be, for the physical layer it is bits, it is responsible for transmitting bits. Data link layer frame, network layer is here it is called as datagram. The payload at the transport layer is segment or user datagram, and at the application layer it is message. So what will be the addresses at each layer? At the link layer, data link layer, it is link layer addresses. Network layer, it is logical address. Transport layer, it is port address. Application layer, domain names. So far we have seen encapsulation and decapsulation, and also TCP IP protocols. So with this we can have some MCQs. Look at this. We are going to have 10 MCQs. Look at these two. First, look at the first two MCQs. The TCP IP protocol suite is organized into how many layers? Which layer of TCP IP model is responsible for carrying in individual bits across the link? The result is 5 layers. Physical layer is responsible for transmitting individual bits. Data link layer encapsulates a datagram into a, so what will be the identical object in the data link layer? Which protocol helps IP to report problems in a routing of a packet? So we have seen the protocol used by IP to find the link layer address, and which protocol layer is connection oriented protocol, provides error flow and error control. Answer is ARP, as well as here it is TCP IP. UDP will be the connection less protocol. Which of the following is the connection less protocol? Now only we have seen UDP. The application IP protocol is used for accessing World Wide Web. HTTP. SMTP is for electronic mail services. And the last two, the process of adding headers at each layer, whether it is adding as encapsulation or decapsulation. Which protocol at the application layer is used to map host names to the IP address? Host names. It's nothing but DNS. So that's all. Thank you for your patient listening.